So let us start our lecture today, and according to our schedule, with this week and next 2 weeks we will discuss object-oriented programming. Okay, so please give attention. Object-oriented programming is a new concept, not new, a new concept for us for this class course. Okay, so far we discussed procedure-oriented programming concept. That was the foundation of we discussed variable, data types, or operand expressions, right? Selection statement, repetition statements, and functions. And there is one more main element left, that is array or list. We will discuss this. Now let us start object-oriented programming. Okay? Object-oriented programming is a new concept for us, maybe some of you, but this is really interesting. The concept of object-oriented programming here is that we will develop our program or application like in real life fashion. For instance, what is meant by real life fashion? Okay, we will create our new type. So far we discussed our programs with integer type data or float type data or string type data. Remember that an integer type variable can contain only integer value. Okay, it cannot contain string value, we know that. But our normal variable cannot contain a combination of different multiple data, right? Okay, but in general, if we are able to create a data type that is a compound data type, then our programming will be easier. For instance, if we say student, okay, a student, if we can create a student as a type, then what will be our advantages? Some advantages, like we can say a student has an ID, right? That may be an integer type. A student has that is a string type. A student has a age, maybe that is an integer type. A student has weight, that is maybe float type. Student has some GPA test scores, right? That is a float type. So a student has a gender, maybe either M for male or F for female. That will be character type. Okay. Or another Boolean type, or has graduated or not, yes or no, right? That would be Boolean type. So in combination of these multiple types, more than one, if we can create a new data type, then our programming will be easier. And another concept, sometimes in real life we inherit properties from our parent, our grandparents, right? So in programming we can inherit properties. That means there is something existing method or variables in one class in some place, and if we can reuse that, then our life will be easier. Like when we if we inherit properties from our parent or our grandparent, then our life become easier, right? Become wealthy very soon. Otherwise, think about that. If everyone has to their own income, then sometimes life would be difficult, right? But now in real life, our life is easier. Sometimes when our parents have some property, we inherit. So in object-oriented programming concept, we will be able to see how can we inherit properties from some other place. Then our programming will be easier. So the concept of programming in object-oriented programming is that we will develop program or application in real-life fashion. So what is meant by real-life fashion? Okay, so the foundation of object-oriented programming is two things: class and object. An object is an entity. Everything in this world you see is an object. For instance, as a human, I am an object. As a human, you are an object. Michael is an object, right? Okay. The pen is an object. Paper is an object. This table is an object. This building is an object. The universe, the whole world is another object. Sometimes we can see an object. Sometimes we do not see, but realize. For instance, Wi-Fi connection, internet connection, electricity. We cannot see it, but we realize their strength. Those are objects as well as. Right? And sometimes we combined one or more objects to make a larger object. Right? How this building was developed. It has many objects. Some pins starting from a very small pin, okay, nail to starting from very large wood, or then very large, maybe heavy bricks, and then other stuff. Okay, so we will see that we'll see some interesting thing when we learn object-oriented programming concept. Two things here: object and class. So what is a class? Class means is a type. In general, think about that. A class is like a data type, something a type. Okay. For instance, in real life, what do we mean by a type? A class. For instance, student class. It's a student, okay? And if we say teacher, you see that there are some special characteristics or features of a student than a teacher, right? This is why this group of people is student, and this group of people called teacher, right? Or employee. Okay. So when we actually develop a class, then we will see that we can create as many objects of that type, as many instances of that type. An instance of a type is called, of a class type is called an object. We will be able to create an object. And then when we create an object, we will see that our life will be easier programming, in terms of programming. Okay, so a class, for instance, how do there is a very minor difference between a class and an object. How do we say we understand this is a class or this is an object? When you say a name in general, like a common noun, that is a class. For instance, if I say flower, okay, flower is a name, okay, or if I say pen, okay, so if I ask some people, please give me a pen. Okay, maybe Michael will give me a pen. What is your name? Mark will give me a pen. Okay. Jevin will give me another pen. Okay. But your pen is different color, maybe different color, different type, and different brand, right? But these are called pen. Right? So because there are some characteristics of these common characteristics that we can classify this pen, not a computer, not a table. And then when you say in general, a pen, that is a class. When I say brand name, when I say specific pen, for instance, P1, pen 1, or pen 2, or pen 3, red pen, or white pen, or marker, that will be an object. Similarly, for instance, when you say flower, flower in general is a term is called class. Rose, that will be an object. When you say fruits, in general, fruits are class. But when you say banana, banana is an object. You say mango is an object. But if we do more classification, for instance, there are different kinds of bananas. Right? There are different kinds of mangoes, right? In terms of their taste, size, price, weight. More classification. But we will see that later. So So a class contains two things. Okay, some variables. Okay, this is three. The class term. Okay, some variables and some functions. The class contains two things mainly: some variables and some functions. Some variables are used to hold attributes or features of an instance of that class. Okay? And functions are used to define behavior of that of instance. I will come with live and then with live example, then you will understand this. And let me so a class, for now remember that a class contains two things: some variables and some functions to access those variables. The functions, we know that function, right? How to define a function? When a function is defined within a class, that is called function, or it's called behavior, or it's called method or function, member function. Okay. So a class, how do we define a class? Okay, we will start now. We will learn how to define a class. A class is defined in object-oriented programming concepts, starting with the keyword class. In pseudocode, when you write pseudocode, you will write all uppercase like class, and then class name. This is dog. Dog is a class. And how do I know that this is a class? Just starting with class keyword. Okay, then it will say that it is say begin. It says begin and end. There is nothing in between. That is empty class. Okay, but we will define this class. For instance, we say in a programming language like C# and Java, we will start with a keyword class, and then we will give a class name, and this is the opening brace. This is the starting of a class, and the closing brace. This is an ending of the class. Okay, in some languages, C++, a class name ends with a semicolon. If you are taking a class lab, then remember that your class will end with semicolon, but not in C# or Java. So for instance, we want to define a class dog. Okay, so now when you say dog, okay, what do you think? Imagine. Here, the word dog, Michael. What do you imagine? Mark, what do you imagine? An animal. You imagine an animal, right? That has maybe 4 legs in general, a long tail, okay, two nice ears, and then one mouth with some teeth, okay. Yeah, those are the characteristics or features, right? So how do we define or store those features for a dog? If I have a dog named D1, okay, dog object, okay, for instance, we will have a name, right? What is the type of this name? String type, right? Name can be held with the data type. Okay, name is a variable that is string, right? Name, in order to write a name of a dog, we need to put some characters, right? So name will be string type. So then how many leg counts, for instance, leg count, number of legs, right? Number of legs is integer type, right? 4 legs, mostly, but maybe 3 legs. I have seen a dog with 3 legs. Okay, so and it should be age. If you say float type, then 2.5 years or 3 years or 3.5 years, right? But if you say integer, then you have to say uh, only 3 years. You cannot say 3.5 years. You know, in real life, we use something weird word. When someone asks me, how old are you? Say, for instance, we say, I'm 45 years old. Even I am, after next month, after a week, I will be 46. We do not tell that, right? We tell that 45 years old, for instance. We say that I'm 40 years old. But when people ask you, what is your weight? I'm 45, I'm 105.5 pounds. I'm 105.6 pounds. People say usually weight they measure in fluid type, right? But you say that which one would be more accurate? If I would say I'm 40, 150 pounds, that would be more accurate. It's fine. So a few ounces do not matter, right? But months or 10 months out of 12 months is better. Is a matter, right? But in general, we say I'm 45 years until the last day of that year. So this is why, okay. So leg count is integer type and age is fluid type. Okay, and then say is trained or not, we can say Boolean type, right? Trained or not trained, right? Boolean type. And it will have a color and it will have some weight, fluid type, and it will have some other characteristics, like, okay, for instance, these are the data characteristics, okay? These will be used to hold a dog's some data. Okay, a dog, in addition to this data, a dog has some other characteristics, like, for instance, a dog can make sound, right? Can move. For instance, can move. Method. Okay. Okay. Another characteristic a dog can have, for instance, make sound. For instance. Okay. So these are methods. So in general, say we should let us return type is void. Okay. Void. Okay. Don't avoid. Yes. So P should be lowercase. V should be lowercase over here. If should be fluid and P should be boolean. Okay. So when you imagine a dog, we think that a general dog has these characteristics and these features, right? These are the behaviors of a dog. Okay. Now, let me get some volunteers, like 4 volunteers. Okay, I need, if you like a dog or have a dog, then give me a minute, please. Okay. I'm giving you a dog name, for instance, D1. You will write your name of it. It can be a real dog, imaginary name, or you can put a real name. Okay, then you will put how many legs are there for your dog, okay, of your dog. You write down, okay, Michael. And I need 3 more people. Help me. Two. Your name? Okay, I'm sorry. So G3. I need one more person, please. Mark, you wanna help me? Or you wanna help me? Oh. Okay, you will just write down name of your dog. If you have it, then fine, or you can give real name or imaginary name, no problem. Okay, and then leg count. Okay, and make sure that you follow the data type. Okay, so then when you put the name, put your name in double quote. Within double, that is string, right? Put your dog's name in double quote. Okay, and integer leg count should be 4 number, and age you can put 3.5 years or 3.5. You don't need to type in year. Okay, just put 3.5. Okay, is train, yes, say just say yes. Is this a true or false? Boolean, okay. So color, you can say red or white or black or gray. Okay. And weight, you can give an imaginary weight like 50 pounds or 15 pounds or 150 pounds, no matter. Okay. And move. This is a method. You don't need to give this for this two. Okay. I will define this two later. Yes, please. Okay, thank you. Can you please write your name over here so that I remember your name? Oh, what is that? No, I'm fine. You can tell me what's your name? Sam. Okay. Thank you. Very simple, Kumar. Okay, thank you so much. So I got 4 dog instance, okay? This is a piece of paper, but think about that this is a dog. Okay, this is a dog. This dog name has hands. Okay, this is dog 2. Name has hands. And then it has 4 legs and it is 4 month old and this not trained, that means false. Okay, and then brown color and then 18 pounds. Okay, my dog one is named Lacey. 4 legs, it is 3.5 years old and then it is trained and it is black color. It is 45 pounds, right? Okay. And my dog 3, it is named Sasa. Okay, it has 4 legs. It is 3.3 years old, and it is trained true, and color is brown and white, and then weight is 5.2 pounds. Okay, my last dog is D4. That's name is Dante. Okay, and then age is 4 years old, and then that train. It should be, you missed the train. Train is true or false? Okay, true. This is okay, not trained. Okay, not trained, and then 150 weight. Okay, let us think how these are truck. So how do we implement this dog object in our program? In our programming concept, okay? Give attention, please. If you understand this, you will be able to develop any class. For the next 20 minutes, you understand for the next 20 minutes, then you will get a foundation knowledge of object-oriented programming, okay? So, uh, how can I create a new class? Create a new program. I have an example that I discussed in my previous section. Okay. So I define start a class. Okay. I start a class with start class keyword. Okay. Then I will give name of my class name. Okay. Dog. And then I will start from an opening brace. Okay. And I will close with an opening brace. So this is the closing of my class. Okay. So then I will just define the variables I do have class. Okay, my string name is string type. So just I will define his name string, and after every time I will put a semicolon, right? Okay, now this definition is like normal variable decoration, right? Nothing new. But what is new here? I will put this within my class. So my class dog, it has name, string type, it has num count, number of legs, integer type, it has age, float type, and it is a variable is string, that is boolean type, and then color, that is string type, and then weight, that is float type. Let us, for instance, start from this. Let me move these stuffs somewhere. Okay. So this will be my class. Okay. So then I just declared a type. Now I will use this type to create an instance of this type that will be called an object. Okay, so where do we need to create this object? We need to create an object of this type mainly generally in main method, in main method. Okay, let me move this so that you understand better. For instance, I'm starting from scratch. Okay, so this is my main method. For instance, in main method, how do we declare a normal type variable? For instance, we say int x1 will equal to int x1, right? Declare a variable like this x1, regular variable, right? X1 is an integer type. Then how do we define value to this x1? We can say, for instance, x1 equal to 15, right? That's it, right? Or in combination, we can say int, for instance, another variable, for instance, y1 equal to 20. This in one line, right? This one line is similar to the combination of, for instance, these two lines, right? Okay, say maybe x1. Since I cannot have same name variables, so I'm giving another name. For instance, let me put x2, okay? I cannot have same name of two variable in the same program, so I need to give a different name. That's it. So this is a normal way how to declare and assign value of a normal for a normal data type. Everybody understand this, right? But how do we declare or create an instance of a, that is little bit different. So give attention over here. We will use this type. So you see that, remember that we will create our type outside of this class. You see, this is a class, main class, and this is the end of this class. This is the 11, number line 11 is the end of main class. So we will declare our new class outside of this class, okay, not inside. We can create a class inside of a class, but we are not doing that. Okay. For instance, we are creating this dog class outside of my main class. Okay. So here then now we have created our dog class. Then how do we create an instance of this class? Simple. Like for instance, when we wanted to create an instance of primitive data type, we typed in the type first, right? Integer type, right? Similarly, dog is a type, right? So we will type in dog over here. Then we will give my instance name instead of x1, x2, for instance, let me say d1. Then the difference is over here equal to new dog. Here we are using something new. It is new operator. Most of the language is new operator is new, all in lowercase. Okay, and this dog is called constructor. Okay, we will go through constructor later, but for now, this is a method, right? This is a method call, right? You know that whenever we have a parenthesis, this is called a method. Okay, we are calling this this constructor in order to create. We are calling the dog classes constructor in order to create a D1 object. Okay, by the way, as a human, you cannot create something, living being, right? Only God can create a dog. Huh? We are creating an imaginary dog, okay? This imaginary dog, a virtual dog we are creating. For instance, sometimes in real life, we deal with virtual money. When we use credit card, debit card, we just use our virtual money, right? It serves, as long as it serves our purpose, then we are happy. Transfer money, so we are sometimes we transfer virtual money from one account to another account. As long as my serves, then I'm happy with virtual money, right? Even we don't need to see real bill. Okay, so this is a dog, D1, where this is a virtual dog, not a real dog we are creating. But we will see that this D1 will behave like a real dog. And what kind of dog? This kind of dog. That has a name, that has a leg, that has age, and these properties. Not beyond this, okay, for now. So this is the line that we created a dog object, T1. So when we create an instance or variable of a class, then instead of calling this as variable, we will call this as an object. So here x1 is a variable, but d1 we will say that it is a dog, an object. Okay, similarly, we can use same code as many dog instances I need. But remember that I cannot give same name again and again, more than one time. So I need to rename it. Okay, so this is my dog 2, and this is my dog 3, and this is my dog 4, and this is my dog 5, and this is my dog, and so on. As many dog I need, I can create. Okay. How do I assign values for my dog? That is a question. So it was easy that in for a regular variable, we are familiar with this, right? We can say x1 equal to 15. It's easy, right? But for a class type instance or an object, it is much easy. We have to follow a different strategy, because remember that a dog has a name, it has leg, number of legs, it has age, and it is other feature is trained or not. Then how do we assign a name of my dog 1? The way, for instance, for my dog 1 here is Lassie. Okay, so then how do I assign that? I will say d1 dot name equal to LASSIE. Okay, this is the difference. You see, I'm telling that d1 dot, I have name variable, right? Then it is like something like this. I'm saying that d1 apostrophe s, d1's name equal to Lassie. Okay, but we will put, instead of apostrophe s, we will put dot operator. Dot is an operator over here. Okay. So then similarly, if we understand this, we will say d1 dot is, okay, name of legs equal to how many? Is it 4, right? So then 4. So this of legs is an integer type, right? But I cannot say directly name legs, because this name leg is an instance of my dog, part of my dog. Okay. Without a living dog, if you might a leg, if you get a leg of a dog, that is not valuable, right? That is not useful. Okay, so then how can I say similarly d1 dot is equal to how many? You say 3.5? 3.5 years, right? So that, but for instance, we know that if it is a fluid type, then we have to put an F over here. Okay. Okay. And so on. For instance, we can say d1 dot is trained equal to true. Okay. d1 dot color equal to, say, what is the color? Black. Okay. And then d1 dot weight equal to 45 pounds. I'm sorry, this, I don't know how it is moved. This should be, inside this. Okay. The question is that how do we print this value? How do we display this value? Okay, so in regular program, for instance, if we want to display my value, for instance, x1 or x2, how do we print it? We say in Java system dot out dot print ln, I say x1 equal to plus x1, right? It will be printing x1 and it will be printing x2. These are simple and we are familiar with this, right? Okay, but in case of how do we display this one, an object, for instance d1, if we say d1, for instance d1 is over here, if we say d1 equal to plus d1, it will come up with something that we will not be familiar with. Let us run this program, then I will discuss. Okay, we see that this is the output for our first line. We say x1 15, right? Simple, and x2 equal to 20, then it got x2 equal to 20. But for this d1, I got d1 equal to, it is not something meaningful, right? But maybe at least you recognize something, right? Dog. What is it? This dog. So by seeing that, you will remember that dog and then at the rate. That means this is a dog object. And it is data type is dog. You see the dog is coming from here. Dog is coming from here, okay? This is its data type, says new, I said dog. This type is coming here, dog. At the rate, this is a memory location. This is a memory location. Yes. Yes. You can see my code over here. Just you need to go, in order to see my course, you need to go REPL, then .it, then at the rate my username. Then if you go here, then you will be able to see all of my programs that I say more view all REPL. You will see all of the programs that I discussed. So now everybody understand that to display a normal data variable is simple. To display a character, sorry, an object is something not an easy that much. For instance, we are creating here, the reason is that we are creating a data type, new type. That is a combination of several individual types. That means several ingredients. For instance, we are cooking some food with some ingredients. Okay. So how you know how to cook something? What can you cook? Chicken. Oh, okay, that's good. He can cook chicken. Okay, so then when you cook chicken, right, you use some ingredients, right? Chicken, like what are ingredients? Sauce, then the salt, garlic, onions, oil. Okay, that okay. When you cook some, definitely it should be delicious. But when you taste it, right, you can taste it that if you missed salt, if you miss salt, then you can realize that, right? You can taste that, oh, I forgot to add salt, right? Okay, then it's easy to add salt, right? But for instance, it may happen that you some more salt, right? Then you realize that, oh, it is bitter. It's not eatable, right? Now think about that. How difficult it is if you are asked to separate the ingredient after you cook. After you cook some even chicken, is it too easy that to separate the ingredients? It's not easy, right? But it's easy to realize or taste whether my ingredient or whether I put ingredient, right? Similarly, when you are creating, because we are, when you cook something, you combine the ingredients, right? That is why it is not easy to separate. Similarly, when you are creating a DOB object, we are creating this DOB class by combining some features, right? This is why it is not easy. Okay, then later I will show that. That means it is showing that here, but if we want to display like this D1, we will display its memory location. It will tell you that D1 is a class as an object of doctor. No, I'm highlighting something. Just highlight this one. It shows that D1, my D1 is an object of dog type that is located on this memory location. That's it. Okay, but if you want to display what, for instance, name of the dog, then you will say D1's name equal to D1 dot name. Okay, and you will say if you want to display D1's age, okay, age, you will say D1 dot age. If I run this program, it will show me D1's name and D1 age. You see that? Now I got it. D1's name, let's see, and whatever name whatever age I get, I got it, right? So that it is not simple, but not too much, right? What do we need to use? The dot operator. We need to, in order to access a feature of an object, we need to use a dot operator followed by the object name. Now, so far, we have defined only features, only like variables, okay? But for instance, let us add the other two variables. Void can move. My dog can move, for instance, this one. Yeah. Then how do we define how my dog moves? I will define here. Say, we put very something simple. I say my dog can move. Okay. So then, and these are for move, and let us define another method. Make sound, right? I have another method, make sound. For instance, here, frozen. Okay, I have two other variable methods over here, behaviors, can move and make sound. Okay, dog can make, you can sit down. Okay, now how do I call this method? That similar way. If I say d1 dot can move, that's it. Then if I say d1 dot sound, and if I run this program, then it will show me whatever behaviors my dog. These are coming from, you see that this method is coming from, I define over here. So this is the simplest, or this is the way how do we declare a class. Okay, we need to declare a class one time. That's it, okay? And when you declare a class, we need to create object. And when you create object, then later we need to assign values, attributes to each of the individual object. And when you want to access an attribute of an object, we will use dot operator. Okay, that's it for now. Please remember these steps. If you remember this, okay, then from our next lecture we will go remaining part. Okay, thank you so much.